So last class we discussed about the um, types of excitation. The excitation will be classified, and what are the different types of excitation? Excitation is nothing but a DC current is given to the field circuit. So depending upon that excitation, generators are classified into mainly two types: separately excited and self-excited. And then self-excited again classified into DC shunt, DC series, and DC compound. So depending upon the connection, DC compound generator is also again classified into long shunt, short shunt, right? And we have to draw the equation, sorry, circuit diagrams. Depending upon the circuit diagrams, we have to draw the voltage current relation, that is voltage current equations of a DC generator, right? And I'm doing some problems also. Now next topic is characteristics of DC generators. What is meant by characteristic generally? In general, in every equipment or every auxiliary device, the working performance is exactly known with the help of characteristics. That means what is the output, what is the input, and draw the curve between output and input such that that machine may work efficiently or not. So with the help of curve only, we can analyze the device characteristics, device operation. Similarly, characteristics of DC generator is nothing but performance of DC generator in different manners. That is internal characteristics, external characteristics, and no load characteristics. Generally, no load characteristics is nothing but no load or open loop characteristics, OCC, or you can call it as magnetization characteristics. That is mainly drawn between no load EMF versus field current. Whereas in load characteristics, drawn between voltage versus IL and EMF versus IL. So we can briefly explain next slides today class. Sometimes they asking draw the magnetic characteristics of this shunt generator, like 2 marks, right? So before going to the characteristics, first of all, we know the voltage building in a self-excited generator. Voltage building in a self-excited generator, otherwise build-up of EMF in a self-excited generator, otherwise conditions to generate the voltage in a self-excited generator means how to generate the EMF in a practical generators. So to generate the EMF, what are the necessary conditions? Generally, for every generator which is used as a self-excited generator, there must exist some residual magnetic flux. What is the residual magnetic flux means? Before purchasing the generator, so at the time of manufacturing time, they will manufacture and then the generator is tested. At the time of testing, they will started giving the supply such that motor may run, generator may running, it will produce some voltage. After that, they will shut down. They will switch off the supply and they will purchase the generator to consumers. So once a consumer purchased the generator and again he started in his work, at that time already some EMF is induced in the generator at the initial stage. That will be added directly here. So that a small amount of EMF readily given by the generator is called residual voltage. What is the reason for residual voltage is nothing but residual magnetism. What is the meaning of residual magnetism is nothing but, so that is, so at the time of manufacturing they will test the generator. At that time, whenever they given the supply to the generator, that generator may develop the EMF. That EMF not nullified at the time of testing. They will just leave it and they purchase and they sell down to the consumers. So now consumer may utilize that generator is nothing but already a small amount of voltage is generated at the testing time. That generating voltage now adding to the present voltage. Suppose at the testing time they will operate it, 230 volts will be generated, they will shut down, they will switch off the supply, 230 volts will be reducing, but at 10 volts or 12 volts, so that 12 volts or 10 volts not nullifying. That means it does not comes to zero. So the 10 volts, 12 volts will be remaining in the generator. Now consumer may start the generator. So again he will get the 230 volts, but at the starting the values are not coming to zero. The value is directly going to the above 12. From 12 onwards the voltage will be generated, 12, 20, 50 like that. So what is the reason is nothing but because of residual magnetism. That voltage is called residual voltage. Very important. So a laboratory experiment is also there in our ET lab. So that will clearly shown by the laboratory. So the, to build up voltage, what is the main condition is nothing but there must be a residual magnetism. Second one, the connection of the field winding should be such that field flux aids the residual flux. So till now I am discussed. So already residual flux is there. Because of residual flux, some voltage will be appearing, 12 volts. Now main flux is there. Because of main flux, some voltage will be producing. Now these two will be adding. So voltage will be increasing. Next, the resistance of the field circuit should be less than the critical resistance. So field circuit resistance must be always less than the critical field resistance. And speed greater than the critical speed. So these are the main conditions. Generally, when the armature rotates, conductor cuts the small residual flux to produce EMF. This EMF is called residual voltage. This small EMF may drive the field winding. Thus field current IF now produce more flux which is greater than the residual flux. Hence more EMF is induced. And this further drives more current through the field to produce more flux, and this process will be continuous. That is nothing but cumulative. This process is cumulative and continuous till rated voltage gets appeared or till rated voltage gets built up. Right? This is This is the main reason to build up the EMF, right? So definition, very important definition. Critical field resistance. It is the resistance of the field circuit at given speed at which generator just excited. That is nothing but at this resistance generator just excited. Below this resistance generator does not excited. Right? You got my point? So at critical resistance only generator just excited. Below critical resistance generator does not excited. Right? What is critical speed? It is the speed at which machine just exit for the now go for the characteristics of a DC generators. So I'm already telling magnetization characteristics are open circuit characteristics or no load saturation characteristics, whatever it may be. That is nothing but it is drawn between the no load EMF versus field current. No load EMF in the sense E naught. Then load characteristics. Load characteristics is nothing but internal characteristics and external characteristics. Internal characteristics curve is a relation between the load generated EMF and armature current. Whereas external characteristics, terminal voltage versus load current. This is the characteristics of separately excited generator. So starting from the 0 onwards, it will be increasing. Why? Because this is a separately excited. For self-excited, residual magnetism will appear. So this is no load voltage and field current. Generally, here this is the rheostat to control the field. Rheostat is used to control the field current IF. Why? Because by varying the rheostat from 0 to some position, then the ammeter may show the some value. What is the value is nothing but field current value. So to vary the field current value, to vary the rheostat, you can get the field current value. According to that field current values, so note down the voltage in a voltmeter. That is nothing but here, no load voltage. As IF is varied at the starting, suppose we can consider at the starting, rheostat is 0 position and field current is 0. Whenever field current is 0, EMF is also 0. So starting point. Now rheostat is moving. Whenever rheostat is moving, so now the field current may varies such that so EMF value also increases. How can you say that as IF changes, EMF? That is nothing but as IF is varied. IF is nothing but field current. Field is nothing but flux, right? As IF is varied, flux is varied. Whenever flux is varied, EMF is also varied, right? You know the formula, Eg pi z n by 16 dp by A. As pi varies, E also varies, like that. So whenever varying the field current, EMF is also varied, right? Because of flux changes. And no load is connected to machine. Hence, here there is no load. That's why these characteristics are also known as no load characteristics. And the graph is done between E naught versus IF. As IF increases, flux increases and E naught also increases. After some time, suppose look at the figure. So my cursor is at near the N1. So after increasing the IF more and more, so E naught does not changes. Why? Because so the magnets are saturated. Because of magnet saturated, flux becomes constant. When our flux becomes constant, EMF is also constant. So up to some extent, up to rated voltage, the graph will be increasing. That is linear curve. After rated voltage, it will be a constant, straight line, constant value. So OCC follow a straight line up to rated value, then saturated, pi becomes practically constant. Now go for the internal and external characteristics. Let E naught be the no load rated voltage, which drops E due to armature reaction. So this is the armature reaction drop. What is meant by armature reaction is nothing but the effect of field flux on the main flux. The effect of field flux on the main flux, such that the field must be weakened. That is nothing but flux weakens. That is flux decreases. So pi 1 is the main flux, pi 2 is the field flux. Because of pi 2, pi 1 may reduce, that is pi minus pi 2, pi 1 minus pi 2, total net flux is reduces. Whenever net flux is reduces, voltage is also reduces. So this is the AB. AB is rated voltage, that is 230 volts or 220 volts. Now because of armature reaction drop, so it may be at 10 volts, let us consider. So the curve will be like this. So this is the internal characteristics, right? E naught versus IA is the internal characteristics. C is the internal characteristics. Now coming to the external characteristics, because of drop, resistance drop, IA RA drop, that is also losses, right? So that may be highest value. Already because of armature reaction drop, so the voltage may be reduced to 10 volts. That is nothing but, so AB is the 220 and AC is the 210. Now AD is 200. Because of ohmic drop, or ohmic drop is nothing but IARA drop. So because of armature reaction drop, that is nothing but flux reduces. Flux reduce means voltage is also reduces. So these are the internal and external characteristics of a separately excited. Now shunt generator. Shunt generator is also same, ditto. So magnetization characteristics is also same, and this internal external characteristics is also same. Generally, ideally, the induced EMF is not dependent on the load current. Exactly, you cannot say that EMF does not depending upon the IL. EMF depending upon the flux, speed, right? So like that parameters, so not in IL. But as load current increases, armature current IA is also increases. Therefore, IA increases, armature flux also increases. Generally, there is no direct connection for EMF and load current. But as load current increases, IA increases. IA increases, flux also increases. And flux increases, EMF also increases. As usual, so these two, internal and external characteristics, because of armature drop, some voltage will be reduced. Because of ohmic drop, some voltage will be reduced, as usual. So look at the series generator. So look at the A. So internal, external started from the 0, but magnetization characteristics is not started from the 0. Right? OCC curve started from the A. So what is this A? OA is nothing but so residual voltage. Residual voltage. Residual voltage is because of residual flux. Right? Why? Series generator will starting from the 0 is nothing but here we know that for series generator armature current and series current field current and load current all are same, right? As load current increases, ISC increases such that flux is directly proportional to ISC. So that's why starting from the 0 itself, remaining all starting from the rated voltage, shunt generator from the rated voltage it will be reduces, but coming to the series generator, so it will be starting from the origin because of series current. All current are same, so series current is directly proportional to the flux, hence induced EMF also increases. Thus the characteristics E against is a increasing nature, whereas shunt generator decreasing nature or drooping characteristics. But coming to the series generator, the increasing characteristics or rising characteristics. As IA increases, armature reaction increases, but its effect is negligible. So that's why this is the internal characteristics and this is the external characteristics. Now coming to the last one, compound generator. The characteristics of a compound generator may depends on the whether generator is cumulatively compounded or differentially compounded. Cumulatively compound means both shunt and series field are aiding or not. So it is aiding, you can call it as cumulative compound. It will differ, you can call it as differential compound. Suppose it is a cumulative compound, what about the flux? Pi total is equal to pi sh plus pi sc. కాంపౌండ్ జనరేటర్లో షంట్ ఫీల్డ్ ఉంటుంది, సిరీస్ ఫీల్డ్ ఉంటుంది. సో అది కుములేటివ్ కాంపౌండా లేకపోతే డిఫరెన్షియల్ కాంపౌండ్ అనే దాన్ని బట్టి సో వీ హ్యావ్ టు డ్రా ద క్యారెక్టరిస్టిక్స్. Cumulative compound is nothing but addition of shunt flux and series flux, that is nothing but total flux. As the load current increases, IA also increases, hence ILC also increases, so may produce more flux. Thus induced EMF is also increases and terminal voltage also increases. So here A cumulative compound and differential compound. Again, cumulative compound classified over compound, flat compound, under compound. So plant compound is nothing but there is no drops. So you can neglect armature drop, you can neglect ohmic drop. Then only we are getting the flat compounded generator, 230 volts only. Suppose over compound is nothing but the voltage is more than the rated voltage. Then only we are getting the over compound generator characteristics. Suppose the voltage is less than the rated voltage. That is nothing but because of ohmic drop armature reaction. So the voltage may reduce to less than the rated voltage. That is AD is the under compound, AC is the flat compound, and AB is the over compounded. Look at the last topic of first unit, applications of DC generators. Generally, the generators may practically utilized in various applications. First, separately excited DC generator may utilize the electroplating and boosters. Electroplating means we have to arcing, welding, all these things nothing but electroplating. Booster is nothing but to increase the voltage in a transmission lines. That is the booster. And it may utilized in lighting and power purpose. Coming to the self-excited or shunt generator, mainly it is used to ordinary lighting and battery charging also. Ordinary lighting purpose and also battery charging purpose. Why? Because it is a constant speed. Next, series. So it is having highest speed. That's why electric arc lamps and it is used as a booster, constant current generator. And sometimes they may utilized in traction also. Compound generator, cumulative compound is mainly utilized. Differential compound is not utilized practically. So electric arc furnaces, we are utilizing electric arc furnaces mainly, right? So these are the applications of DC generator. So before to discuss the characteristics, characteristics is the main important. They are asking question like this: explain the load characteristics of a shunt generator. Load is nothing but internal, external. Internal means because of armature reaction drop, the voltage may reduced somewhat less than the rated voltage. External means because of ohmic drop, the voltage may again reduced somewhat less than the rated voltage and internal characteristics. External characteristics is always lies below the internal characteristics. Internal characteristics always lies below the rated voltage. This is about first unit. So we discuss the operation of a DC generator, construction of a DC generator, EMF equation of a DC generator, some problems, types of DC generator, that is excitation, types of excitation, problems, then voltage build up, how to build the voltage in a self-excited generator, What is the critical field resistance? What is the critical speed? After then, we discuss the characteristics, that is magnetization characteristics, then load characteristics, that is internal and external characteristics of every generator. All are same maximum, separately shunt, all are same, both are same, series will be differ and compound will be differ. They asking mainly shunt generator only. That's why load characteristics of shunt generator is nothing but rated voltage upper, below internal, below external. And critical speed is nothing but, so the speed changes, open circuit characteristic also changes for different shunt field resistances. So we have to draw the curve. Generally, we know the OCC curve. OCC curve is drawn between the no load EMF versus field current, right? Now, slope of that OCC curve is nothing but, so critical resistance. Any doubts?